Right now, we are looking at an abstract model of an energetic current flowing through a precise geometric grid. Our objective today is to neutrally document the exact manufacturing parameters and assembly protocols required to construct Magrav and alternative plasma-based health systems. The efficacy of these units relies entirely on strict, cascading, bottom-up manufacturing. A single structural deviation early in the build will prevent the completed hardware from functioning. This rotating wireframe illustrates the ultimate macro assembly, the full health system array. It features a specific dual-wall structure, specialized capacitors, and a saline grounding bath. To construct it, we divide the process into 3 pillars: material transformation, component architecture, and system integration. Skipping steps or ignoring topological rules at the chemical or component level ensures the macro system will fail to hold a charge or direct the plasma field correctly. Proper plasma engineering is a strict, sequential discipline. The smallest atomic error at the start cascades into total systemic failure at the end. We begin with Phase 1, material preparation. Before any hardware is assembled, raw copper must be altered into a nano-coated state. This footage demonstrates the thermal method, the required protocol for energy-focused components. Notice how the shiny copper oxidizes, turning uniformly dark under the flame. The thermal execution parameters are incredibly strict. You must torch the copper uniformly from top to bottom, using only the tip of the flame, moving in a single consistent direction. Pushing the copper to a red-hot overheat will destroy the process. Immediately following the heat application, the torched copper must be quenched in cold water to rapidly thicken and lock the newly formed nanolayer. This illustration contrasts the thermal method on the left with the caustic vapor method on the right. The caustic method is required for health-based components. Instead of fire, the caustic parameters utilize a slow cooker. The copper is suspended over a continuous caustic soda vapor for several hours, allowing the chemical reaction to achieve a deep black penetration into the metal without thermal stress. Copper treated with caustic vapor must then adhere to a mandatory electrical polarization rule. You must polarize the wire using a multimeter set to the highest resistance setting to ensure the energy flows unidirectionally. Without a uniform, properly polarized nanocoat, the copper cannot bridge the gap to external plasma fields. We turn next to synthesizing the active plasma compound, GANs, or gas in a nanostate. To produce CO2 Gans, suspend pure zinc and a nano-coated copper plate in saline, linked by a circuit. A white substance detaches, settling below. If stalled, scratch the copper's nanolayer, attach a negative terminal there, positive to the zinc, and aerate the water. You are now handling an operational hazard. The newly formed raw GANs mixture is heavily saline and highly toxic to biological systems. This flowchart maps the mandatory washing protocol. First, extract the raw sediment from the saline bath. Mix it into a high volume of pure water, typically 100 milliliters of GANs to a liter of water. Let it settle and decant the top water. This exact cycle of dilution, settling, and decanting must be repeated a minimum of 4 times. The final validation test uses the decanted top water. It must possess 0 salty taste before the GANs is applied to plants or health hardware. Skipping the washing protocol leaves toxic salinity intact. Proper chemical refinement is the strict barrier determining whether the biological interface will be beneficial or destructive. With the chemical synthesis complete, we transition to structural engineering. The raw materials are now organized into plasma battery capacitors. The capacitor begins with a nano-coated copper core, surrounded by plastic insulation. Next is paper infused with iron, copper, and zinc GANs. Heavy metals are strictly prohibited. Finally, half the unit is shielded in aluminum foil, with copper coils wound across both sections. The main Magrav system coils require strict mathematical winding ratios for resonance. The inner coil needs exactly 81 turns, while the outer coil demands 144 turns. Furthermore, an absolute directional constraint applies. All coils must be wound in the exact same direction. Rigid mathematical ratios and topological alignment invert passive nanomaterials into active, directional energy conduits. The final phase integrates these localized components into macro architectures built specifically to interface with human subjects. A minimal, localized setup, like a health pen, requires only a single component utilizing strictly CO2 Gans. A full system, however, is a massive multi-array installation. This top-down schematic maps the full health system. It features a dual-wall configuration populated with nested coils, powered by plasma battery capacitors, with a central target space. Energy pushes outward from the active emitter wall, passes through the subject space, and impacts the passive receiver wall. This introduces a non-negotiable hardware constraint. Energy cannot be allowed to pool in the receiver wall. The system requires a physical grounding mechanism. The final terminal exiting the receiver wall must be safely discharged. The bare wire drops down and fully submerges into a liquid bath. The discharge bath has a strict chemical requirement. It must maintain a minimum of a 5% saline solution to correctly and safely dissipate the accumulated plasma field. A plasma array acts as an open circuit. Failing to ground the receiver side into saline creates a stagnant field. The system may appear structurally complete, but operationally it is broken. We have to pull back from the physical blueprints and address the final, most complex variable in the entire system, the biological operator. We have covered a massive scale of engineering, tracing the process from atomic-level chemical burns to rigid mathematical winding ratios and saline dissipation tanks. According to the Foundation's theory, this physical complexity is secondary. The hardware cannot independently initiate a biological change or neutralize a disease pattern. The array is designed to function as a resonance chamber. Its magnetic gravitational fields are built to match the frequency of the human aura, creating a shared plasma environment between the copper coils and the biological subject. In this shared environment, the system acts as an amplifier for the user. By matching the operator's biological field, the hardware captures and feeds internal cognitive patterns back into the user's framework, making the operator the primary driver of their own systemic regulation. Engineering the hardware to exact specifications only provides 50% of the architecture. The system remains fundamentally incomplete without the integrated biocognitive intent of the human operator.